After this video, you should be able to illustrate the different properties of operations on the set of integers. When we're talking about operations, these are your addition, subtraction, multiplication, and division. When we're talking about the set of integers, these are your whole numbers, 0, 1, 2, 3, and so on, and their inverse. -1, -2, -3, and so on. This can be denoted as Z. Let's start off with the first property, and that is closure. And let's look at it with the fundamental operations: addition, subtraction, multiplication, and division. And remember, all our numbers are in integers. When you're going to add two integers, is it also going to be an integer? That is the question closure is asking. And yes, it is true for addition. In a more formal way to write this, it's going to be the sum of two numbers. It's going to be an element also in integers. It is also true for subtraction. If we find the difference of two numbers, it is also, if we find the difference of two integers, it will also be an integer. For multiplication, it is also true. When you multiply two integers, it will also give you an integer. But for division, it's not going to be true. If you're going to divide one integer with another, will it be also an integer? It will not always be true. An example of this, let's just take the numbers 3 and 5. 3 plus 5 is 8. 3 and 5 are integers. Their sum, 8, is also an integer. 3 minus 5 is equals to -2. 3 and -5 are integers, and -2 is also an integer. 3 times 5 is 15. 3 and 5 are integers, and 15 is also an integer. And we have 3 divided by 5, and then we have 3 divided by 5 is just 3/5, and this is not an integer. So for closure, it is true for addition, subtraction, and multiplication, but not for division. Next, we have commutative property. And same thing, let's do it with addition, subtraction, multiplication, and division. It's asking whether A plus B, or two numbers, if we switch their places to B plus A, is it going to be the same? For addition, it's going to be true, and also for multiplication, but not true for subtraction and division. Let's give an example. 3 plus 5, is it going to be the same as 5 plus 3? 3 plus 5 is 8. Is it the same as 5 plus 3? Yes. How about 3 minus 5? The same as saying 5 minus 3. 3 minus 5 is -2. 5 minus 3 is 2. So not the same. Let's have 3 times 5. Is it the same as saying 5 times 3? We have 15 on the left-hand side and 15 also on the right-hand side. We have 3 divided by 5 and 5 divided by 3. This is going to be 3/5, and this is going to be 5/3. And they are not the same. So it's true for addition and multiplication, but not true for subtraction and division. Next, we have distributive property. And it's only going to be addition and subtraction. And it's asking if the product of a number and a sum, is it the same as saying the sum of their products? So A was distributed to B and C. Same thing here. A product of a number and a difference, is it the same as saying the difference of their product? Let's have an example. 3 times 5 plus 4, is it the same as saying 3 times 5 plus 3 times 4. By order of operations, let's do the one inside the parentheses. 5 plus 4 is 9. We have multiplications here. This is going to be 15 plus 3 times 4 is 12. And on the left hand side, it's going to be 3 times 9, which is 27. The sum of 15 and 12 is also 27. Let's do it here. Let's do it for subtraction. 3 times the quantity 5 minus 4. Is it the same as saying 3 times 5 minus 3 times 4? Order of operations. 5 minus 4 is 1. Then we have 3. 3 times 5 is 15. Minus 3 times 4 is 12. Left hand side is going to be 3. Difference of 15 and 12 is also 3. So it's going to be true for addition and subtraction, but not applicable for multiplication and division. Then we have the final property, which is identity. We have only two, which is for addition and multiplication. And it's going to ask, what number can I add to any number that will also give me that number? For addition, that is going to be 0. Even if you change the position using commutative property, it is going to be the same. For multiplication, what number can I multiply that can give me that number also? For multiplication, that is 1. Using commutative property, we have 1 times a, and that is going to be a. So 0 is called the additive identity. And for multiplication, 1 is called multiplicative identity. Let's end it off with an example. 3 plus the additive identity would give you 3. The additive identity plus 5 will also give you 5. For multiplication, 3 times the multiplicative identity would give you 3, and the multiplicative identity times 5 will also give you that number. That's it. End.